Good morning, boys and girls. It's Miss Messina from Team Cortland again.
Hi guys, it's Mr. Schwartz from Team Cortland.
Hi, boys and girls. It's Mrs. Viola from Team Geneseo.
Hi, everybody. It's Mrs. Cabrera from Team Stony Brook.
Hi, guys. It's Miss Hidalgo from Team Geneseo.
So, boys and girls, last week we learned that there are 118 different atoms that make up all the materials in the universe. Trees, air, rocks, and us were all made up out of the same 118 different kinds of atoms.
How is this possible?
Well, same way that we mix them all up into many different words, we can mix them up into millions of stories. The atoms can combine into different ways to make different molecules, and those different molecules can make up many millions of different materials. How does this happen?
We'll review what happens during a physical change and what happens during a chemical change. Let's go over different aspects of physical change. When atoms and molecules speed up or slow down, that is a physical change. When they change states from a liquid to a solid or to form from a gas to a liquid, that is also a physical change. When a substance is dissolved by water or some other solvent, a new substance has not really been formed. The molecules still come back together to form the original substance.
However, in a chemical change, the atoms in the reactants rearrange themselves and bond together differently to form one or more new products with different characteristics than the reactants. When a new substance is formed, the change is called a chemical change.
In most chemical reactions, two or more substances called reactants interact to create different substances called products. A burning candle is an example of a chemical reaction.
Thank you. So how is a burning candle an example of a chemical reaction? Because we have talked to you about burning is a chemical reaction before. We said that was chemical energy. So let's take a look at this burning candle. What do you think the reactants are in this burning candle? The reactants are wax and oxygen from the air are the reactants. They combine together and change their molecules around until they make a product. A lot of kids think that the string is burning, but if I lit the string and the wick by itself, it would burn up in a minute or two, and I can leave this candle burning for about an hour. So you know it is the wax that's burning. One of the major characteristics of a chemical reaction is that the reactants combine in new and different ways from the molecules of the products. So it's not the string so much, it's the wax that's going up the wick and burning. So are you surprised that water can be produced? In this case, we're making, the wax is combining with the oxygen and it's making carbon dioxide and water. Are you surprised that we're making water? Because we can extinguish fire with water. It might be strange that water is actually produced in combustion. But if you think about it, when you burn food in your bodies, what do you produce? You're producing carbon dioxide that you breathe out and water. You put your hand over your mouth for a while, you'll feel that it gets moist because you're breathing out not just carbon dioxide, you're also breathing out water. So remember, air is a mixture of gases. When something burns, it's reacting with the oxygen in the air that's all around us. So I want you to predict, if I put this jar over the top of the flame, what will happen? I'm going to put it very carefully over the flame. Make your prediction, and what will happen? Did you notice how the flame went out? Why did that happen? So placing the jar over the flame limits the amount of oxygen that the candle can have. With no oxygen, you can't have the chemical reaction and the fire will go out. So the wax will no longer mix in with the oxygen and separate. We're going to go and look at a chemical reaction between methane and oxygen right now.
What are some other examples of chemical reactions?
So looking here, we can see a chemical reaction happening between methane and oxygen. So methane and oxygen in this scenario would be the reactants. Their bonds start to break apart, and then their atoms rearrange themselves to create new bonds and to form products or new molecules. In this case, they are forming carbon dioxide and water. Where do the atoms come from that make the carbon dioxide and the water on the right side of this equation? The atoms in the products come from the atoms in the reactants. Remember that in a chemical reaction, bonds between atoms in the reactants are broken, and the atoms rearrange themselves to form new bonds to make products.
So boys and girls, in a chemical reaction, new bonds form between atoms to form molecules. Miss Viola will demonstrate how you can create molecules at home. Here are the materials you need, or just watch along with Miss Viola. Either way works. The materials you will need if you decide to do this with Miss Viola are model cutouts, a sheet of colored paper or construction paper, colored pencils, a scissor, glue or tape.
Okay, so the procedure to prepare the atoms, you're going to cut out circles. You're going to color the carbon atoms black, so you need 1 carbon atom. You're going to color the oxygen atoms red, and you need 4 of those atoms. You're going to leave the hydrogen atoms white, and you need 4 of those as well. Please use your scissors carefully to cut out those atoms. And now we're going to build molecules. Hi, boys and girls. So now that we have our atoms cut out, what you need to do is chemically combine them to make molecules. So if you take 2 hydrogen atoms and 1 oxygen atom, and they chemically combine, they will give us a molecule of H2O, which is water. That's what H2O means, 2 atoms of hydrogen, 1 atom of oxygen. If you wanted to combine 2 atoms of oxygen, that will give us a molecule of oxygen. So 2 atoms of oxygen chemically combined give us a molecule of oxygen. And now here with your carbon atom, if you add, you get a molecule of methane, CH4. So whenever you see a molecule, each capital letter is a different atom. So capital C is for carbon, capital H is for hydrogen, and this number here, which we call a subscript, is how many atoms there are. There are 4 atoms of hydrogen, 1, 2, 3, 4. And if there isn't a subscript written, it's a 1. We don't write the 1s. So it's just CH4. Back again over here for oxygen, it's O2, 2 atoms of oxygen. And over here, we write H2O. For 2 atoms of hydrogen and 1 atom of oxygen. Again, we don't write the 1. And that gives you a molecule of water.
So we see how molecules form. Now when 2 different molecules come together, they actually react to produce new molecules. So here you're going to see how the atoms in methane and oxygen separate out and recombine, rearrange themselves to create new molecules, right? So here we have 2 molecules of water being created and a molecule of carbon dioxide from the methane and the oxygen.